So thank you for the invitation. I apologize for not able to be engaging with all the expertise in this area. So I'm going to share our journey, especially from Singapore perspective on this Open 6G research, which I'll elaborate a bit more on that. So the background of this is that we have a future comms program that we started in 2021. This is a phase one of a Singapore million, about 68.7 million initial investment. With this investment, we try to build an ecosystem, and I'll elaborate on some of the initiative related to this Open 6G research. So with that, a few areas that we actually built upon, URCC, security, ISAC, NTN, MEC, these are projects that we started internally in Singapore across different universities and research institutes. Likewise, as what Professor Yoshida has mentioned, this is to have open ecosystem to have internet different nations together, also with Future Forum and others, and key partners in industry as well as consortium. So definitely we hope to be part of this XG, that international platform that Professor Yoshida has mentioned earlier. What is actually important is that unlike most of the program that we've done, we are focusing on building an ecosystem through testbed and translation grant through industry. I'll elaborate more on this testbed building, which is a platform of Open 6G. So the platform itself is based on 3GPP. It's an open rank standard. It's modularized. It's software reconfigurable. But I actually want to go into details of why this is important to us and how is it related to ecosystem as well as applications and future technologies related to 6G. So if you look at 6G, or we call it XG, how this is related to this open platform, at our lab at the SUT, we call FCC lab, it's actually all in one store that provide full services in R&D. But important is test integration and system integration, which is unlike in the past where you have a test bed which focuses purely on R&D. It is important that we feel that it's important to also do test and integration, because that's how we bring ecosystem in, and also system integration, especially when AI comes along. So there's a lot of system integration, data-led building, and so on. So if we look at this precisely on this area, which we call Open 6G research, SUTD, we're trying to drive this what is called Open RAN or Open Research as a pathway for beyond 5G, where we focus a few key important areas: security, how does zero trust can bring into the system. We know that in the 5G standard, 15 to 17 or 18, zero trust is not actually inside, but there's a lot of focus on zero trust. How do we bring zero trust into actually 5G, also in 5G and beyond? Sustainability becomes a very important topic that all of us are looking at, and that's why system integration certification important, because how do you actually even quantify end-to-end sustainability measures? We will see a lot of new architecture coming in, especially with the introduction of NTN 3D network across. New form of architecture will come, integration of ISAC and so on. So what are the new architecture, especially with security and sustainability constraint? Spectrum management becomes an important particular for Singapore context, especially if you look at NTN. It covers a really big footprint. How the spectrum management comes along with ISAC and other technology. Spectrum becomes an issue. We talk about FR3, FR2 MM wave has not been adopted, so we're looking at how does MM wave play a role in the future. A lot of this is talk about test bed, because we need to understand the use case, when will it be used for what, and test bed becomes an important functionality for us. Automation ML is going to be the key for a lot of areas, because we know that a lot of functionality requires automation, bring in the flexibility. So AI ML becomes good. So in all, we're trying to bring all this into a test and integration center, which is sort of OTIC under ORAN Alliance, but it can be more general, because we're going to bring NTN together with this OTIC as our roadmap, which I'll elaborate a bit more. So in short, if I put in the picture, this is what we are building at. So we have a few open programmable networks, a single vendor. We also have multi-vendor, which I elaborate what are the multi-vendors we have. We also have OAI, which is open source programmable type of. So we'll be organizing OAI workshop actually in next year. Within all these test bed, we are connecting the verticals of applications, where Joe and Reno, which I'll show you a use case. A campus, like a cyber physical campus. For example, in Germany, where I'm currently now, there's a big push on this campus network concept. We also want to bring in metaverse as a potential use case in the future. How does metaverse from indoor move outwards? How does connectivity play a big role? Within all this, test and integration, which I mentioned, is important. Bring certification is important, badging, so that actually that's how we bring the ecosystem in. That's how we bring testing, looking at end-to-end, sustainability, security. And one important area that in the future for this community is look at how does AI can be actually be certified and to test. And because we will have different applications coming, which we call it RAN intelligent controller. Under the RAN intelligent controller, we have different applications like XF and RX, which I elaborate more some of the efforts we are doing. With that, we furthermore bring in emulation or sort of a range. That is, we have end-to-end test bed setting up in the process, a 5G conventional base station setting up for security. We have also a maritime board, a maritime ship or test bed setting up. And imagine all this will be connected. If all these are connected, then what are the use case we can actually elaborate? We can actually look at a use case of a handphone or device on a boat, on a ship, being connected to the satellite. Then when the ship moves towards close the range of the base station to the shore, how this can be actually hand over to an terrestrial base station. All this needs to be verified in a control environment to understand the implication, whether it's security, whether it's implication of performance end-to-end. Because it's very hard to actually have a real ship, real satellite to able to do POC or to do trial. So this is essentially important in a control environment so that actually we understand all the different performance. With that, some of these key partners are here. I'll just, it's not exhaustive, it's just some of the partners that we have. So elaborate about test bed. So this was a single vendor test bed that we have, but more important is that we have FR1, FR2. We're in discussion of FR3 for some experiment with different companies. So these are the multi-vendor ORAN vendors that we are working on across the different areas of the topic. With that, there's an open source programmable network, which is OAI. So this is something you want to try more new functionality or 6G technology. This is a Nokia network that will actually link up to my other networks to look at security, cyber range, and use cases. So this is the drone area. Let me see if I can show a short video what this can be done. I hope that this can be seen. Yeah, so as an example, what we are trying to show is that AR, VR, you can actually control a drone from our control environment using XR goggles, and essentially you control a drone remotely. You can actually bring the metaverse context into that. So these are the things that we can do. We can actually do end-to-end, which is, for example, XR end-to-end is a big area in 5G and beyond. So this is just an example. I'll not take up too much time. I'll elaborate some of these other concepts. Cyber physical campus is one concept that we've been actually throwing out very early, because at university, as a use case, we want to think about how will future technologies change the way education change, right? Because you influence a lot of students, future generation. The use of XR, how will you change the use of sensors and so on? And it's a private sort of a campus network that you actually can look at the different functionality, different use case, and this is very important to look at that. I've mentioned a bit on connectivity. This is also an ongoing process, which we are working with different partners on that. We see a potential of new market, new economy in Web3 and beyond in the future. And how does it relate to the new connectivity that will drive this. This is important because all these connectivity, whether it's 5G or 6G, needs to bring economic impact to our country or our companies. So digital twin is a very interesting because once you have actually a test bed with all the new functionality of 6G, it's actually very difficult for operators or different even private network companies or SI to really understand if I introduce any new technology, what is implication or how does AI play a role. So it's important once you have this test bed with the SMO, which is our intelligent controller, build a digital twin upon it, and this digital twin can collect all the different data in the actual physical network, regenerate a functional model in another space to understand how would generative AI play a role, how would new functionality, how would channel measurement or model play a role. This will actually give us another new functionality to understand if we bring new technologies or even how does sustainability work in this actual new deployment. So I'll elaborate a bit with the remaining time on this OTIC, which we are trying to drive. We try to drive a leadership in this role, particularly on sustainability, security, in terms of certification and some verticals we have mentioned. So our vision is actually not beyond just open platform. We actually bring the NTN together. So our vision is to build a 6G NTN test bed integrated with this open platform. So that's why I mentioned it's an open 6G research, because we'll see new functionality in NTN, whether it's satellite, LEO, GEO, MEO, or HYPS, able to integrate across the LAN, but with new platforms, for example, regenerative satellite, splitting architecture, new way of connecting across the land or sea. So we need to do a lot of testing and certification. So we see that there's a lot of commonality between these two types of technologies coming into one. So this is our vision down the road, where we actually will bring them together, and we hope to organize events like PlugFest and beyond, and we invite international partners to work with us to actually also bring partners together with us. So these are some of the services we are providing to our customers. This is free now. We are trying to also work with different companies for that. So these are the capability we are building. So these are PlugFest we are actually running now all the way to end of May together with Northeastern University's OTIC to try to do some of these sharing. So it's actually important to do this international partnership, which we feel is important so that we leverage on different capability. So last part is on the industry PlugFest. So what we are trying to do in this new form of Singapore's perspective, how do we actually plug into the system? So we focus a lot on all this industry event. So one of them is actually MWC Mobile World Congress. So we're actively trying to work with partners to do demonstration at Mobile World Congress. So this is one very different areas that we are pushing. Secondly, we're trying to take part in different competitions. So this is one competition that's driven by NTIA in US. So we just came back from this event in Dallas in March. So there was 38 applicants all around the world. 10 were selected. So we're actually very honored that Singapore or SUTD was selected only one. So actually, what are we demoing this? So I'll just quickly give you an idea what our AI platform where we did. So we're actually using our test bed. We have an outdoor cell, indoor cell. So we have a robotic that is moving across this intercell on an N78. So the robotic platforms is connected by outdoor arena through other vendor. So I'm going to build a rig upon it, video intelligent controller on this. This is purely an uplink. Essentially, I have an indoor cell, which is a classroom, which I mentioned. This is also another platform, which also has a rig that is purely downlink on AR, VR. Goggles, very high speed downlink. So essentially, you have this robot move across the region. It will actually detect if I close to interference between the other cell. I will use my AI to automatically control my power in a millisecond downlink power control and also avoid this interference. So all this is based on a purely automation through AI ML with some machine model, which I'll not elaborate due to time constraint, because I think I have only 2 more minutes. So what's my future plan? So my future plan now, currently we are planning the 2.0, which is called FCP 2.0, from 2025 next year to 2030. So likely the amount of budget we're planning for this will be much higher than the current phase 1. So we want to continue on this direction of focusing on trust. We will broaden this open RAN into calling trust. It could be open platform, it could be trust AI ML becomes one. NTN will be an important area we continue to build upon because it's related to a key sector like maritime aviation. It's important to Singapore resilience and economic. New functionality as like Isaac and RIS are something we're interested to build upon. But the key focus of this is essentially has to be strategic, has to solve national challenges, globally relevant, and globally competitive, impactful research translation project together with our international partners like all of you and also industry. At the end, we want to really support our economy. We'll continue to build test-bed infra, which is a centerpiece to understand the new functionality, to push technologies ahead. And we'll ramp up international linkage to foster research collaborations much stronger than before. And with that, I thank you for your time, and I really apologize for not being with you at Nanjing. Thank you. Thank you.